another fun-filled adventure in math with Mr. Sims. Today we're going to be talking about permutations and combinations, which is a really fun topic. Permutations and combinations, what you're looking at with this particular concept is with permutations, what you're looking at is, let's say you have a whole bunch of things and you want to pull out maybe 3 things from that particular set to make a subset, right? So you want to pull out 3 things, maybe to get 3 different positions or something like that, right? So with permutations, the order matters. Okay, so when you're doing it, let's say this might be a situation where you have a first, second, and third place. Well, if you ask the first, second, and third place people, right, obviously it's going to matter to Jill, Bob, and Sue, right, what place they get, right? So it does matter to them that order that they get there, right? But there's other things that doesn't matter as much. For instance, and those things are called combinations. Those orders don't matter. Like maybe there are 3 things, right? Like maybe you go to Pizza Hut and they have a great deal where they're saying, hey, you can choose any 3 toppings. Maybe they have like 25 different toppings up here, right? But they say, hey, you can choose any 3 to go on here. And let's say you chose, pepperoni, anchovies, right? And I don't know, sausage, right? So let's say these are the 3 things you choose, right, on your pizza. Hey, I won't judge, right? It does not matter to you which position the pepperoni goes in or which position the anchovy. You're not going to look at your pizza and go, oh my gosh, I cannot believe that they put the pepperoni on before the anchovies. No, you're not going to do that, right? You're going to put the pepperoni and anchovies and sausage. It doesn't matter how they go on as long as those 3 end up on your pizza, right? So that's an example of a combination. Permutation, the order matters. Combination, the order does not matter. All right, and I'm actually going to show you the related equations that go with this, right? In all of these, by the way, we are making situations where there is no repetition. We're choosing to make situations where there is no repetition. There are situations where repetition occurs, but we're not going to deal with those tonight, and instead we're just going to deal with ones that have no repetition. So let me talk about what the equation looks like for permutations where you have no repetition. What the equation is n factorial over n minus r. That is so ugly. N minus r factorial. And what this is here, this n stands for the total number of things I have that I can choose from. All right, so let's say there were 27 people who ran this race. Then my n is 27. So that's 27 factorial, right? That would be 27 factorial, which really means 27 times 26 times 25 times 24, all the way to times 1. Okay, so that's what 27 factorial means. And then I would put that over n minus r factorial, which is 27 minus r. Your r value is going to be how many places you choose. So this one would be 27 minus 3, and then I'm going to do factorial, all right? And anyway, that's the basic equation for this, right? But we're going to go ahead and do some examples here where you can see it all worked out. But I just wanted to show you the basic equation that you're looking at is this one right here, okay? Now, the good news for you is there is a super easy way to do this because you have these fancy calculators. Man, when I was young, we had to do it with blood, sweat, and tears, and we walked uphill both ways through the snow, and we liked it. That's right, you heard me. So anyway, so here, this, you guys have a really nice way to do it, but this is how I had to do it. It was ugly. I'm going to show you how to do it on the calculator to make it way easier on you, okay? And once again, for this one here, this one would be slightly different. This one is, once again, a combination, and you'll notice that the equation is going to be very similar. You have the n factorial over the n minus r, and you're thinking, wow, Mr. Sims, that is exactly what you just wrote, and you would be absolutely 100% correct in that. That is exactly what I just wrote on this side, but I have one more thing to do. I have to multiply it times r factorial. And the reason I'm multiplying it times r factorial, basically what I'm doing is I'm saying these are all the possible combinations I could have, right? Then I only want the possible combinations from basically these 3 spaces, right? But remember, when you do permutations, we're saying the order matters. So we're going to get more combinations. Like let's say we had Jill, Bob, and Sue. Well, Jill, Bob, and Sue in here is one way of one permutation, but there's also Bob, Jill, right, and Sue, right? And there's also Bob, Sue, and Jill, right? It's the same three people, but they're organized different ways. Well, permutation thinks that each of those is a different way of organizing that set, right? With combinations, that doesn't matter. Like I said, it doesn't matter if it's pepperoni, anchovies, sausage, pepperoni, sausage, anchovies. You don't care as long as there's pepperonis, anchovies, and sausage on there, right? So in this case, the order doesn't matter. So our factorial that we divide it by here is getting rid of those extra options that occur because of the order mattering, okay? So that's why you divide it by this r factorial here, okay? And you don't have to understand that so much, but I did want to give you the background so you understand where this is coming from. The good news for you is you have this beautiful, beautiful, beautiful calculator function that's just going to make you so unbelievably happy. You have no idea. So let's go ahead and do some of these problems, and I will show you that you can still get the answer. It'll just be so ugly the other way. So here we go. So the bowling team at Lincoln High School must choose a president, vice president, and secretary. All right? So if the team has 14 members, right? 14 members, which expression could be used to determine the number of ways the officers could be chosen? I've already put the right answer there, right? So we can get to it. But what we're going to do with this one is the pool of people that we're choosing from. There are 14 people in that pool. So that's going to be our n value. Our n is equal to 14. Now notice they want to choose a president, a vice president, and a secretary. Now my question for you is, does the order matter? Hopefully you said the order does matter, because it does. If you're one of those people, you're going to be very happy to be president, maybe not so happy to be secretary. Or maybe you're just not a presidential person, you like the secretary position, then you're going to prefer that, right? So yes, the order definitely matters in this case, right? It definitely matters. So what we need to realize is that this is going to be what we call a permutation. Because with a permutation, the order matters, right? The order matters. That is so ugly handwriting, but you get it. The order matters. So I'm going to take my n equals 14, and I'm choosing a total of 3 positions, all right? So my number of positions, or my r, is 3. So what this really is this is an example of what we call n PR. That P stands for permutations, right? And the n value is going to be 14, so it's going to be 14 PR. Not PR. The R value is 3, so 14 P3. Now you're probably wondering why I'm writing it like this, and there is a good reason for me writing it like this. But before I get to that good reason, I'm going to go ahead and do the actual math to do it, because I just like math. Okay, here we go. Yes, so we're going to start with the permutations. Once again, my formula is n factorial over n minus r factorial. And I'm just going to say that's equal to n, once again, is 14, so that's going to be 14 factorial, right? All I've done is substituted in for n, over 14 minus my r value, which is 3, once again, factorial. So if I actually calculate this out now, what I have here is I have, my brain just stopped. Okay, I have, this is going to be 14 times 13 times 12 times 11 times 10. And you know what? I am not going to do all this. I could totally do those in a calculator without anything. But the nice thing is we have a beautiful calculator which can help us. So I'm just going to clear some stuff here. I'm going to clear all this stuff, gunk, right? And hopefully you can see this, right? So in my calculator, I'm going to do 14 factorial. 14, and I'm going to factorial that puppy dog. All right, the way I factorial that is I go to math, I go over to probability, and I go down to this cool exclamation point, which is factorial. Once again, factorial means 14 times 13 times 12 times 10 times 11 times 9 wait, times 14 times 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 6 times 5 times 4 times 3 times 2 times 1. That's what 14 factorial means, right? But we're just going to do 14 factorial, and it's going to do it for us, and that is that huge evil number. That's 14 factorial. Obviously, as you can see, it goes up super fast. So I'm going to divide that number now by 14 minus 3, right? Factorial. So I'm going to go math. And you really could do each of these in one step, right? I'm going to do that beautiful little factorial button again. Look at that. Looks so cute, right? And we're going to hit enter. And we get a total of 2184, which should be the answer if I did it right. I did do it right. Oh, that feels good. All right, so that's 2184, right? So that's 2,184 possible different ways, possible different permutations that we can make with that number of students. In other words, we could have 2,184 different scenarios that play out based on picking a president, vice president, and secretary where the order matters, right? 2184. Now, I promised I would show you this magical button, and I'm going to show you the magical button because I'm a man of my word. So here we go. Let's go to the magical button. The nice thing about the magical button is you go to Math, Probability, and I wrote this on purpose as NPR, right, which is 14P3. So I'm going to go to this NPR here, and I'm going to hit enter. And it's going to bring up this P where I got these two cute little boxes next to it. I'm going to put 14, as you can imagine, in that first box, and 3 in that second box. And watch what happens. The magic happens that gives me 2184. I didn't even need to know how to do this equation here, which makes Mr. Sim super sad, by the way. Hashtag sad face. But anyway, for you, for your test, hashtag happy face. So you know how to get that now. That's a beautiful way to do it. I suggest you do it that way because that will just make you more successful, right? If you want to practice this way just for fun, that's fine. But make sure you know how to do that in your calculator. And by the way, the little TI, whatever they're called, also have it, right? If you have the, I don't have that emulator on this particular software, but the little handheld TI scientific calculators, I forget what they're called, they also have the button there, and I can show you how to get that if you want. Moving on to the next one. Here we go. There are 20 people on a basketball team, and the coach needs to choose 5 to put into a game. How many different possible ways can the coach choose a team of 5 if each person has an equal chance of being selected? Now, with this one, I don't like this problem. And I know those of you who are on the basketball team, you're like, you know what, Coach, you cannot choose me for center, right? But I have to tell you, this problem doesn't take that into account. And that makes me super sad because I think like you, if you're a basketball player, that the order should matter, maybe. But in this particular case, it does not. They do not want it to matter. They're just saying, hey, we're just making a team, right? We're just making a team of 5 people. We're not thinking about the positions at all. We're just saying, choose 5 people to go in, right? Put 5 people in. So what we're going to do, once again, this order does not matter. So if it does not matter, then this is what's going to be called a combination, which is super cool. All right, so this combination now, to find this combination, what I'm going to do is I need to find basically an NC So I need to figure out my N. My N is going to be the pool of people I'm choosing from, which is 20 people. Yay! And the coach needs to choose 5 to put into a game. All right, so he wants to choose 5 to put into a game. Well, if he wants to do that, that means there's a total of 5 slots. And as I mentioned before, order does not matter. But we do have the 5 slots, right? Which means my R is going to be 5. So once again, my N equals 20, my R equals 5, and I'm going to go ahead and do the formula because, you know what? Why not? Now, you don't have to, but I want you to see that it still works out. So I have N factorial, which is 20 factorial, over R factorial, which is going to be 5 factorial, times 20 minus 5 factorial. Now what I'm going to do is I'm going to go ahead and type this all in my handy dandy calculator right? I'm going to I'm going to use lots of parentheses, so we're really clear how this is all working, right? I don't want you to get confused at all. So we're going to do 20 factorial, right? There we go. How do you like those sound effects? Yeah, I'll be here all year with those. All right, here we go. So then I'm going to put this all in parentheses, which with, so I'm going to have 5, once again, factorial. Oh, not alpha, math. Oh, I didn't want to do that. Oh, just wrecking it more and more. Here we go. I'll have to go back and fix that later. All right, so 5 factorial, let me get rid of that A that's going to mess everything up. 5 factorial times 20 minus 5 factorial, which is what? Which is this one here. Now, if you're thinking this is way too much fun on a Tuesday night, you're absolutely right. But let's go ahead and do this. Actually, it's a Monday night right now. You guys will see it on Tuesday. Here we go. So when I hit enter, I should get a big, nice number, which is 15,504, which is the number, by the way, that is the answer. Now, let's do it the way that you're loving to do it, right? Because once again, that is a way to do it, but I highly suggest when you're taking a test that you do it what's easy. Right, so once again, you put in your 20 for your N, your C, your R value is 5. So 20 C5 is going to give me, where'd my calculator go? There. So 20 C5, we go to math, right? Go to probability, go to NCR, hit enter. I get 20 C5. And I hit enter, and I get 15,504. Isn't that beautiful? You know that's beautiful, right? It looks gorgeous. All right, moving on to the next one. All right. Do 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 do. A pizza shop has a lot of toppings. Da 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 da. All right, moving on here. A pizza shop has available toppings of sausage, olives, mushrooms, onions. That is a lot of different toppings, but not nearly enough still. 1, 2, 3, 4, 5, 6, 7, 8. Was that 8? 1, 2, 3, 4. 5, 6, 7, 8 toppings? Dude, cool. So there are a total of 8 possible toppings that you can draw from, right? That's your pool that you can draw from. How many different ways can a pizza be made with 3 toppings? 1, 2, 3. My question for you is, does the order matter? Matter. If you chose the answer that the order does not matter, you are 100% correct and not a pizza snob, which should make you feel handsome. Awesome, I meant to say. Well, handsome too. Why not? All right. So with this, it doesn't matter, right? If you choose bacon, pepperoni, and peppers, you don't care which one they put on first, or you shouldn't. Frankly, if you care that much, you shouldn't be eating pizza. All right, moving on. I don't know. That made no sense. But moving on. What you have here is, because the order does not matter, you have a combination. Because with combination, the order does not matter. Once again, order does not matter. Okay? So I'm going to go ahead and figure out my N. My N is equal to what? My N is equal to 8, right? We saw 8 toppings, right? 8 possible toppings to draw from, and we're choosing to draw 3 toppings, which is my R, right? So really, all it is N CR, where I have 8 C3. And I'm not going to torture you by actually doing the math for you. I know. But if you want to do the math, you can go ahead and do it. But 8C3 is what you would type into your calculator. When you type that in, let's see how it works. So I go to math, go over to probability, right? 8, this one here. So I have 8C3, right? And I hit enter, and I get 56, which is the correct answer. Winner, chicken dinner. Now, if I had done that, the actual way, it would have still worked out, by the way, in case you're wondering. But just to make you happy, I'm not doing it with the math. Sad face, but you get the idea, right? All right, so 56 is the correct answer here. There's 56 different ways that we could choose 3 toppings out of the 8, okay? Let's go on and move to the next one, okay? All right, here I want you to go ahead and tackle this one before I even talk about it. So go ahead and think about it for a second. Which one would this be? Permutation or combination? All right, hopefully you figured out this is in fact a permutation because there's 23 students in a race, right? They're all running, 23 great students running in a race, right? That's a total of 23 people in that race. And how many different arrangements of first, second, and third place are possible? So there's 3 slots to fill, the first, the second, and the third slot, right? So my n then is this 23. My r value is 3. And all that's left to be found is, does the order matter? Now, hopefully you came to the conclusion that the order matters, because if you're that person running, it matters very much to you if you are in the first or the third place, right? So this is, because the order matters, this is an example of a permutation, because with permutation, order matters. All right, so this is going to be an example of 23 P3, right? That's how you would write that, right? And once again, if you type that into your handy dandy calculator, which is over here, I should get math probability to NPR, because we're doing permutation this time, right? So I am doing, what was it? 23P3? 23P3. Enter. 10,626. Winner, chicken dinner. Okay, let's go ahead and do 2 more, and then we're going to call it good. Okay, the principal would like to assemble a committee of 5 students from the 10-member student council. How many different committees can be chosen? So you have 10 total people to draw from, right? And you're assembling a committee of 5 students. 1, 2, 3, 4, 5. Right? And so what I'm looking at here, the question is, does the order matter? Now, if you said the order matters, you're thinking that maybe that the principal is choosing them for particular positions. But it doesn't say he's doing that. In fact, all he's doing is taking and making a 5-person committee, right? It doesn't say that he's choosing them for specific jobs or anything like that. So really, he's just taking 5 people. So in fact, the order in this case does not matter. So this is what we call a combination, because the order doesn't matter. So once again, our n value is 10, right? Our r value is 5. So this is an example of 10C5. All right? And when you do 10C5, when you do 10C5, right, you should get 10C5, enter, you should get 252. If you got 252, congratulations, you are on the right track. This beautiful 252 right here is gorgeous. All right, let's go ahead. Last problem, then you can go. There are 12 different actors auditioning for the roles of Larry, Curly, Moe. I really like this one, by the way. How many ways could the roles be cast? So question for you is, does the order matter? If you said the order does not matter, that would be incorrect, because if you're one of those actors, it matters very much to you which part you get. You might not want to be Moe. You might want to be Larry or Curly, right? So depending on the particular role you want, it's going to matter, right? So this would be an example of what we call a permutation, because the order very much matters to you. So remember, with permutations, order matters. I don't know why I feel like I have to echo that each time. But anyway, you have 12 different actors, right? And of the 12 different actors, you're choosing 3 different roles. One for Larry, Curly, and Moe, right? So my N is 12. My R is 3. That becomes N, which is PR, which is 12P3, which is in my calculator very soon. 12P3. Enter, which is 1,320. which is the answer, and it makes me feel happy to get it right, and it makes me feel happy that you are here getting the help you need. Once again, I just want to stress to you always, please listen super carefully to me in this. Hey, I really do care about you guys very much, and I want you to be successful. So please, 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 my suggestion to you is always, always, always get the help you need. Tutorials are oftentimes empty because no one comes, right? So if tutorials are empty, then let's face it, something's not right. If you're struggling and you're not at tutorials and you're not doing homework and you're not doing those things, that's bad, right? You're not helping yourself be successful. But this is a good step for you. I really hope this helped. If it did, great. If it didn't, well, I'm sorry. But that's all I got for you. Just remember, permutations, order matters. Combination, order does not matter. Use that wonderful calculator trick. Learn the math because, hey, math is fun, right? But anyway, aside from that, have a great day, and I'll talk to you later.